Swayam Prabha. Digital India. Educated India.
So in this session we will mainly talk about SimaPro software. We have been in the past few days we have been talking more about the life cycle assessment, LCA thinking and all that. Now we want to calculate something and get numbers out of some scenarios that we have created. Like in this project you have created many process flow diagrams. You have calculated or put many emission factors, emissions associated to different different processes involved in those flow diagrams. How to calculate those and get the real impact assessment results. So for that we need to perform those calculations in softwares. There are different softwares available for doing the comprehensive life cycle assessment. SimaPro is one of them and it is licensed, and there are other free softwares available like OpenLCA, Umberto. But in this presentation I will be talking more about the SimaPro software. During the presentation I will be toggling between the this PPT and also SimaPro software. So please pardon, it will be like I have to, since how many of you have worked on SimaPro software doing LCA, performing LCA? So nowadays this sustainability and LCA, evaluation of LCA has become very essential because of many factors, like in 70% of the corporate, like in corporate systems they have included sustainability as their prime agenda. Then government led initiatives to private led initiatives, then also to meet national wide, like nationally determined contributions. So government is also pushing forward to do more sustainable development assessments and also create country specific emission database and all those. All LCA majorly in SimaPro also we the basics of the SimaPro software or LCA framework is based on this ISO 14040. I think it is all covered in the previous presentations. I will not go much into this. And the core process involved in any LCA based on the ISO 14040 are goal and scope. First, inventory, life cycle inventory development, then impact assessment and also interpretation. And this is also an iterative process. So after getting interpretations from one cycle, then we may again go back to goal and scope, then we may redefine some of the inventory based on the results that we have got while doing the LCA whole LCA process. We might have came across different process to add in those. So it's an iterative process, and this is the ISO is a foundation. It's not telling you to do exactly like this. So this is the basics for or foundation for the LCA software. Then so these are the so let's come to SimaPro software. These are some of the advantages of using SimaPro software. So I am not going in much detail into the, like, I'm not here to advertise the SimaPro software. You can use different other softwares also. So since we are talking about SimaPro here, these are some of the advantages you can see. Let's get started, like how to do the life cycle assessment in SimaPro software or any process. The first thing you would have to do is to clearly sketch down or clearly define the different processes that are involved, or flow diagram of the different processes. This is an example for life cycle assessment of a cycle. So in your project also you might have, the first thing you might have done is to clearly write down or sketch down what are the different processes involved, divide that into different unit processes, and then add on different emissions associated to those, then recycling process or waste disposal scenarios. This is how we start any LCA project. So here this is an example of a cycle, life cycle assessment of a cycle, cycling for 1 lakh kilometer over a lifetime of 15 years. So this functional unit is very important in order to compare different systems. We need to make the functional unit similar. For example, if you are talking about milk packaging, like one is using carton and one is using bottle, so you cannot make a comparison from different materials, but what we can do is to make the functional unit comparable, like delivery of 1 liter of milk to consumers. Like this, some of the other examples, for example, transportation and water purification. So let's now get start with LCA with SimaPro. SimaPro software, this is the first interface that you will face. So here it will be shown, like different projects are shown in this software. So I have created some of the projects here. So we can go to one tutorial. This is how you will enter into any project. Then libraries, in the inventory, processes, product stages. In product stages there are assembly, life cycle, disposal scenario, disassembly, reuse. Then these are some of the other functionalities that we have in the SimaPro. So here I have selected, so these are the different libraries that we have in SimaPro. If you can see, like from the package itself we had received agri footprint, eco invent database, input and output database, industry data 2.0 methods, US LCA, some of the libraries that we have got already with the package. In the right portion you can see some of the icons and associated functionalities that you will find in SimaPro software. Libraries, existing libraries. So in library you can select whichever library that you want. For example, if you are doing a project that is in Europe or India, then you may not select the US LCA, because that may not be included or that may not be required for your LCA inventory, and it will also reduce the chance of entering a mismatched inventory into your life cycle inventory, mismatched process into your life cycle inventory. And let's go to the goal and scope of the project. So here you will be given the space to enter all the data related to the project, like name, like author, content, comments. You can clearly define your or describe your goal and scope, but you can always come back and as you progress through your LCA analysis, you can come back and redefine this process. That's, like I said, it's an iterative process. So these are the how we should define our goal, system boundaries, etc. Like goal definition should be intended, like we should target the audience, intended application, the reasons. It should clearly define the reason why we are doing this process. And the system boundaries also, like whether we are including the capital goods or infrastructure that are associated to the processes. And also here is an example, like for smartphone, what are the system boundaries that we have included, like raw materials, manufacturing, transport, use phase, end of life. let's go to next one is libraries in Golan scope. Like I explained in the previous I shown, like these are the different libraries that are available. The libraries itself are like two types of libraries are there. One is process data library and another one is input output data library. Data library emissions associated to different processes, for example emissions associated to transportation and all. Input output databases are those which are associated to economics, buying something from some region, what are the environmental impact associated to buying goods for this X amount of euro from Y region in agricultural sector in Europe, something like that. So these are the different types of libraries that are available. And this is overview of the modeling that is used in SimaPro, like the resource and emissions from nature connected to like what are the processes and material energy, different emissions associated to those in technosphere. Then in the product stage we have assembly, whole life cycle assessment, then disassembly, reuse, disposal scenarios. So this is the overview of modeling in SimaPro. Then let's go to processes, unit and system processes. So there are two, if you follow the database in SimaPro or any lifecycle assessment software, you might have seen like there are two different processes available. One is unit process and another is system processes. The unit processes is more the emissions associated to unit process is connected with the background data, while the emissions in the background data associated to system processes are involved are provided in the same box. That is the major difference. So when you select these processes in your project, it is better to it depends on your need and all, of course, but to make the inventory light, it is better to use the system process. So let's go to SimaPro and create one process here. So in this presentation, my objective is to take you to SimaPro, like interfaces, what are the different functionalities available. We have been talking about the LCA process, then how exactly it is done in the software. So once you define all the goal definition, functional unit of the project that you are intend to do, you can then start preparing different processes. So when you come to the inventory, first one will be processes, and as ma'am was mentioning in her previous presentation, that many of these processes are already defined. So these processes are there because we have selected different libraries, and from previous studies or the databases that we have, like Echo Invent, these many processes are already defined. So if you go to any one of these processes, you can see, so aluminum alloy metal matrix composite and global market for aluminum alloy metal matrix composite system. So for making 1 kilogram of kilogram mass of this aluminum alloy, these are the materials, resources that are required or taken from nature. Also we can, it is important to see the description of these processes, because there it will be written like for which region it is this particular process is defined, what are the considerations, assumptions, or this basically gives geography. All these details you will find in documentation, and in the input output tab you will see what are the resources that are taken to define this process. from water. So this is how you create these libraries. And the advantage of using this SimaPro software is that or this databases is that for your particular project you can directly select this process. If that alloy is required in your product assembly or in your process, you can directly take this you can directly take the help of this databases. So if you want to create one new process here, so you can select a new, maybe new category, and in that you can create new process. So like for example, your for your region, particularly in South India or Indian region, you are creating or you are manufacturing one alloy. So here you can input the name of the alloy, and if you have the inventory data, maybe it is available from the company side or manufacturer side, like in the last presentation, like EPD and all. These are some of the areas where you can collect data from, and you can input that data and you can create your own inventory. You can keep it with you, and as you work on different projects, it will be useful. So towards the end I will show I am working towards end I will show one of the projects that I am working on. So it is related to developing LCA frameworks for solid waste management strategies in India. So I have modeled one composting plant and also one biogas plant. So then you will get more idea how I have created these processes and worked on calculating the impact assessments associated to that. So this is how you create the processes. Then there are waste scenarios also. So this is also another kind of process that is there. Better not to go in that. Basically it will be useful if you are doing the end of life scenario. So there are waste disposal scenarios, like the SimaPro itself has predefined how different materials will go into different streams of waste treatment technologies. So this is like I said, how to enter and build data. This is the interface that you will face in the SimaPro software, and this is how it will look like once you enter the data. Like for example, here to create aluminum frame of 1.5 kg. So these are the different materials that are that they have used to create that unit. For example, aluminum powder coat, aluminum sheet, impact extrusion of aluminum, welding arc, then input from technosphere like electricity, medium voltage. So this is how you create the process in SimaPro software. So then there are two types of LCA analysis. One is consequential analysis and one is attributional. The difference is that consequential analysis is for different processes. For example, you are modeling like transportation is a process, right? Transportation. So that's a consequential analysis, and attribution analysis is for different products. For example, the water bottle, PET water bottle, etc. And another major important thing to see is the allocation hierarchy.
Could you please repeat the difference between
So consequential analysis for different processes, and the attributional LCA is for the products. And here it is written for the allocation system. So allocation, like for example, if you go back to the this, here you can see the allocation here. So here the product is only single product is there. If we are getting multiple products out of a process, then we may have to give allocation based on different. So on what basis we will give allocation? That is provided in this slide. Like what are the different bases? Like we can give based on the avoid allocation. Like for example, one process is giving say biogas and carbon dioxide, or your production of one like pyrolysis process, you are getting pyro oil and syngas. So what could be the allocation for environmental impacts, whether it should be based on the material quantity, or whether it should be based on their economic value, or whether it should be based on the environmental impact that it will create on the in the impact. But we cannot because we have not done the environmental impact assessment yet. So how we will know what is the impact percentage based on the environmental impact? So we can use different methods. So it is better to it depends on your like context. So whether to go with the material like mass, energy, or whether to go with economical value, that depends on in what context you are doing the LCA analysis, what is the audience need. For example, if you are doing it for company, they may be more concerned about the economic value, or if you are doing it purely on the environmental basis, it is better to give allocation based on the environmental impact. So like that. So next is to like in the previous presentation it is already covered, like what are foreground data and what are background data. So foreground data are some like for example, a company is directly collecting those data or directly monitoring those data, and background data we get mostly from literature or assumptions, or from different other studies. And what weightage should be given to accuracy? The foreground data must be more accurate, and it since they are collecting it from first person point of view, like it will be highly precise and there will be low uncertainty. But for background data like secondary data, it might have low precision and higher uncertainty. For example, like this you can see melting energy, can forming coating materials for can, for example the packaged drinking cans, they are already monitored in the company, and that can be a foreground data. Background data can be the like electricity grid mix, like transport of aluminum, scrap collection. So you get a, like in the previous presentation also he was explaining those.
The data that we just chose right now, the processes that we chose till now, that will come in then background data, right? Because that was not our direct measurement, right? The library that you just chose.
Yeah, in the library there are different types of.
Aluminum thing that we chose, that will
Okay.
go in the background data, right? Because that is not our direct measurement.
Which one?
The previous one.
This one?
That this, like, if you're not creating it, you said.
No, it depends on where from where you are collecting the data.
Yeah, right.
So if you are getting this data from a company itself, like in their EPD, so that's a foreground data.
Then foreground.
Yeah.
If we are picking it from
If-
some in the
If you are picking it,
literature or some library, then it becomes.
yeah, then it becomes. See, these are so this data may be collected from company also, not necessarily from library. Yeah. So this is so once you create these processes, so different processes you have created. For example, you are So this is an example for comparing different materials used for cycle frame. Okay, so you have created processes using different materials in the SimaPro for the cycle frame. Now you can compare the environmental impacts associated to these different processes. There is a compare module available in SimaPro. So for example, you can select this, and then here is the compare module. So these are the different processes, like suppose these are the processes that you have created newly in the SimaPro software. You can compare the environmental impact associated to these processes by clicking here, and here I have selected, let's take recipe midpoint. I will come to the selection of the methods in a little while. Then by calculating we get so since those two processes were very similar, it is not showing much difference between the processes. So this, it will show like these are the different impact categories that was selected for this particular method, and for any such treatment, any such processes that you have created, by clicking this compare icon or that module, you can get an idea of environmental impact associated to those processes. So right now I selected this recipe midpoint. So these are different impact assessment methods that are available, and how do we make a choice of which impact assessment method should be used? Basically it is more about the deliverables, like, and the audience that we are delivering these impact assessments to. For example, in a company you will get this data, you plan for implementing an LCA study, you defined all the scope definition and created the inventory, did the LCA analysis. So if we are doing it for designers, then it should contain more eco indicators. Eco indicators are like ecology, like impact categories that are related to ecology, like for example eutrophication potential, land use, those like ozone depletion, those categories. And if you are doing it for product managers, then it should contain more like aggregated scores, like the impact categories. For example, it was discussed in the previous presentations that the impact categories have different units. It cannot be compared among themselves, but it can be made comparable by dividing with per personal emission factors, or it can be compared to single score LCA results. So for a product managers, that might be of concern. So we may select some impact assessment method that will give single score environmental impacts. And for an EMS specialist, maybe all the details would be required, so we may include all the impact categories category wise, and also we can include the single score LCA results, like that. So these are the different impact assessment methods that are available in SimaPro. Some of them will give only like GHG potential, global warming potential. Some of them, like recipe midpoint, it will give category wise impact results. And for this aware, it will give you results based on the water usage, depletion of water, what are the water associated footprints. So this is how you select the different impact assessments. So once you create different different processes in SimaPro, and also you are able to compare different processes based on different impact categories. Then there is one module called system assembly for that will come in the product stages. So here you can assemble your different processes into like for example, if you are making the cycle as an example, bike assembly, you can individually create this frame aluminum as different processes: saddle, handlebar, group set, pair of wheels, set of brakes, or for example your bottle, it can contain packaging material, PET. So you in the product assembly stage you can assemble all these product and then evaluate what are the environmental impacts associated to the whole product as a whole. So that is the functionality there as the product assembly. I will just show where it is available in the so it comes in the product stages in the assembly. Once you click, so here you can, like for example, if it is for bike assembly, and from here you can select different processes that you have already created. So when I am giving some examples, like you can think about your own project and how it would be modeled in the SimaPro software. So this is another functionality. Then in the life cycle you can so it will give the whole comprehensive life cycle assessment impact associated to those processes. So these are the different impact categories, and ma'am already explained about the characterization factor. So based on the requirements we can select which impact category is needed, and based on that we can select which calculation method should be followed. So here climate change factor for methane for GWP 100 is 28, right? And what is that for 20 years? Short term impact characterization factor, anyone? It was explained in the previous presentation, I think.
Almost 25, 25.9.
No, it is around 80. Yeah. So you can see, like in short term the methane is more dangerous as compared to long terms. So these are the different impact categories and associated characterization factor, how SimaPro is calculating these impacts. Then I think we will not go much deeper like in that uncertainty and sensitivity analysis. It is not covered in the lectures, but basically this is how we will evaluate the data that we are using. For example, we are using transportation like 100-kilometer transportation from the raw material, the source to your processing plant. So if we are certain, are we certain about that is exactly 100-kilometer or not? So we can give some plus or minus 50, plus or minus 20 kilometers, and how much it will impact on the assessment. We can calculate how much it will impact on the assessment. Based on that we can categorize whether that process was, the data quality of that process was very important or not. If we are changing plus or minus 5, and the impact associated to that was varying in a significant way, then we must understand that we should get more accurate data on that particular data set. For example, if it is not varying that much, we may not be required to calculate exact or accurate data of that particular process. So that uncertainty and sensitivity analysis is also available in the SimaPro software. Then comes the normalization and weighing. So basically, like I was saying, like impact categories results may not be comparable because it has different units. So what we do is normalize this result to compare between different impact categories. And also some of your processes may have more weighing based on the environmental impacts. So these can also be done in SimaPro, and that will give you insights. For example, like if you case the scenario for a smartphone LCA, the climate related impact category is giving 0.02, ozone is giving 0.85, acidification 0.04 and eutrophication 0.03. These are the normalized results. So here you can compare among these impact categories. Before the units were different, so you will not be like it was giving for 50 kilogram CO2 equivalent, like GWP it was giving for 50, and the human toxicity impact category it was giving 0.002. But since the units were different, just by looking at the value we may not be able to evaluate. It might be showing very low value in terms of kilogram CFC 11 equivalent, but it may give much more impact. So here you can see ozone depletion after normalization, it is giving 0.85. Even though it was a very small value in units, in absolute units, after normalization we can see that it was giving more impact than the other two. So these are some other examples of like which process is giving or which raw material is giving more impact based on your weightage. So for example, in your refrigerator or smartphone, like ma'am was also saying, like your use phase will be much more environmental, it will give much more environmental impact. So here is an example like that, like use phase it is giving 65% of the total environmental impact. Then manufacturing it contributes about 25%, transport 7%, and end of life 3%. So category wise, then your raw material wise or process wise, you can see how much each process is contributing to the environmental impacts. Waste modeling that I have skipped for, like I told you, like the processes, there are different waste scenarios are also available in SimaPro software, where you can model how your product are product are disposed of, or end of life cycle assessments are that can be also modeled. So here is a comparative assertion, like how this report should be provided to the public. So ISO 10444 like gives direction for the requirements of public comparative claims. If you are comparing two different processes, say product A and B, and you are comparing the products based on different impact categories like climate change, water use, acidification. So this is a format that you can follow in order to report that to the public. The better option, like impact categories and the value should be clearly mentioned, and also in the in another column it should be clearly mentioned which was the better option. So this can be only it can only be compared when we have consistent functional units or the system boundaries are identical. So all those things should be clearly evaluated and also peer reviewed. Then only you can make that claims to the public. These are some of the real world LCA projects. So I think we can go to Srinivas waste management. So I think yesterday we visited the one of the biogas plants, right? Srinivas waste management. So I think better to I will show you how I have divided the whole system into different unit processes. I think little difficult to work with this mouse. Please pardon. Okay. So this is the you might you can identify this Srinivasa waste management system that we visited during our field trip. So this is the goal and scope for the particular project. So your functional unit is 1 ton of MSW, organic fraction of MSW that is managed. So we have considered 5% of like mixed waste is coming, and after segregation we will get about 95% will be organic fraction. So these are the system boundary. This is the system boundary that we have followed, and the unit processes involved inside the boundary are like collection and transportation of waste to the treatment facility. Then the second is substrate preparation. In the substrate preparation they have this depacker system, grinding, and also conveyor belts are involved, and we have after like substrate preparation also include pumping of the material into one sludge tank was there. And the unit process 3 is the anaerobic digestion unit itself, anaerobic digestion process. The two different outputs that we get out of the processes are biogas and digestate. And unit process 4 is biogas upgradation. They are using membrane filtration, and for digestate management they are using solid liquid separator, and then the solids are converted into fertilizers, not in their facility, but they are sending it to some other facility for composting and transforming that into compost. And there are two different scenarios. For example, the biogas is offset to fuel stations. If you would have seen in the last part, like biogas were compressed, collected, purified, compressed and made into cylinder CNG cylinders, and some percentage of the compressed biogas was sent to fuel stations, and some percentage was sent to biogas to restaurants. So this is the system boundary. This is the inventory that we have created for, you can see, for different different unit processes. They are the inventory that we have created. Some of the I have not clearly mentioned, like what are the assumptions and what we have. It is important to mention like how you got the inventory, how you created, and wherever you have assumed any value, it must be clearly mentioned. So this is the inventory for the different processes, and this is the life cycle impact assessment that we got from those scenarios. So let's go to this process. So you can see here the first unit process was waste collection, right? So when we go to the waste collection, this is the waste collection, and these are some of the materials that we like in the inventory. I have mentioned this, like water from what, then transport of the material to the treatment facility, and maybe there will be methane emissions, like biogenic methane emissions will be there. So you can make, so here you can, if you go to analyze, you will be able to find the different environmental impacts associated to that process. So this is only showing process wise data. Let's go to, yeah, method I did not, okay. So once you analyze, here you have to give the method. As you calculate, you will be able to see so here you can even select what are the different impact categories that you want. You can deselect if you are not concerned about maybe marine ecotoxicity, or like you can, based on your requirements, you can select the different impact categories and find what is the impacts based on the different processes. So once we select all this in the product stage, we would, so this is the assembly for Chennai solid waste management anaerobic digestion scenario 1. Okay, so once we select, I have selected different processes like waste collection, slurry preparation, biogas production, upgradation, digestate management, bio-CNG to fuel station. So based on the so if we want to analyze, analyze the impacts associated to this process after creating the assembly line, you can go and calculate like this. So here you can select whatever the impact categories that are required based on your requirements, and this is like showing like process wise the contribution to environmental impacts process wise. For here the digestate management and bio-CNG to fuel station is giving negative impacts because we have provided like avoided products as composting for the digestate management. Also for bio-CNG we have given avoided products as like the fossil fuels are replaced by bio-CNG. So that's how you calculate these different impact, different how you create these different systems, and then different scenarios can be created. For example, here you are using diesel for your transportation. What if you are using bio-CNG or electric vehicles? So all different types of scenarios can be created and that can be easily analyzed. So I think we will not go much to this uncertainty and sensitivity analysis, and we can have some questions. I can take some questions if you have, then we can wind up this session. So I don't know how many of you will be able to work with the SimaPro, but if you go to go and do it in some other software also, the basic approach will be same. And in the past few days we have been talking about life cycle thinking, so that will create like how you should collect your data, what should be the accuracy, which data set should be given more importance in terms of accuracy, how you create different processes, how you create the system like flow diagram of the whole process, and what unit processes or what processes should be included or excluded based on maybe some processes will be contributing very low GWP. So based on that we can make some cutoff like 0 to 5%. If that is below our cutoff, we may exclude those processes from our whole process. So I think it will be, maybe you are not going to do it in the SimaPro, but it will be helpful in your projects or coming the calculations that you will be doing in your project, this particular project also. So the allocation part, it is while you create different processes. If you have multiple outputs, then you have to give allocation to your outputs. Okay, so the software is providing you environmental impacts, but it depends. It also depends on the the purpose that why you are doing the like impact assessment. So if, like for example, I give an example of like in your company you are optimizing some process like one raw material. So your objective is to reduce the economics or reduce the investments or reduce the total production cost of one particular production line. So you are using some raw materials and some substitute raw materials are also available. So you are comparing with these two different raw materials. So if you are giving like based on if you are giving allocation based on economy, so you are trying to say, if I am reducing this much of cost in my production line, what will be the environmental impact? Basically the output is environmental impact only. This allocation is how you give importance to different outputs
How
that
we
you,
play with the inputs
yeah.
related to economy.
So your objective was to know what are the environmental impacts associated to making profit in a production line. So for that, what will be the environmental impacts? Output will be environmental impacts. Then there are like techno-economic assessment. It's not in SimaPro, but if you are doing some project related to like LCA, that it should include, like nowadays they are asking for like techno-economic assessment. Also social LCA is there. So for this purpose I am only doing the environmental impact assessment. Yeah, I think we can make new library. It is possible because I remember I have read about like making the new library, but we need to be in the manual it is written not to mess with the existing library, but we can always copy the library and we can, as we create the different processes inventory, we are basically creating our own life cycle inventory and library for our specific requirements, for the specific environment that these processes are like performed, like that. So you are using OpenLCA, right? So in that also it is, yeah, it is available. So this particular software was purchased based on for our project. So Professor Indu and Professor Vinu, chemical department, are working on this project. So yeah, this particular one was for 5 lakh. I think it is a PhD version. So one user perpetual licensed PhD version of SimaPro. So there are different like faculty versions are there, which can be used for I think 10 users. 1 year licensed versions are there, it will cost less. So basically, for the scenario 1, we are diverting, or we are offsetting the compressed biogas to fuel stations. So avoid, there we have assumed, like not assumed, we have considered avoided emissions of fossil fuels, since it is going to the fuel stations. So we have considered the fossil fuel avoided emissions. That's why the impact categories are showing negative values for the process uh, process 6, and also it was showing negative values for the digestate management process also, because of the avoided products from avoided products as compost, and avoiding like the fertilizers, NPK fertilizers. So that is one of the challenges that we are currently facing. Like many of these database are not developed for Indian scenario, but there are some databases, like for example electricity grid mix, those are already model for Indian specific emission, Indian specific data inventory. Likewise, some other, of course there are some processes that are Indian specific. For example, transportation, we are using global scenario or rest of the world. So we have to check how they have developed those inventory, on what basis, which region, and is it matching with our our like the trucks or vehicles that we are using. Based on that, we have to select. Some, for many countries, they have developed very extensive database, even for methane emissions from different processes. They are monitoring very keenly and regularly. So we can use those databases, but the question will be how accurate your results are, and it all depends on the accuracy of your database. If your database is accurate and you have followed the methods, processes very clearly, then the insights from that will also be good. So I have joined here in April, and so we are yet to I won't say that I am very expert in this field, but the main challenge that we are facing are the like data availability. Because if we go to, for example, if you go to the biogas, from the biomethanation plant, still data was much reliable and available. When we went to the composting plant, there is no monitoring of this biogenic methane, fugitive methane emissions, or proper tally of how much waste is coming, even for how much waste is coming, how much waste they are processing, and where they are sending this, whether they are able to. So it all depends on ability, then emission factors. Find much difficulties in using the software if I have the inventory, the goal, scope, and all things are defined. It will not take much time. So this is SimaPro. It is very user friendly, and I have not used much other softwares. That's if I think ma'am can some, like you have used different software, so analysis of different softwares. Something like using the software is not the like building the inventory is the much time and calculations, and which things should be included, what to that is the part where we should give more our time and energy. And so it can be learned, and tutorials or easy to use the software, but